Today we are looking at Chapter 6 about triangles, Lesson 2, types of triangles, and this is the second lesson about types of triangles. We already discussed the fact that you can classify triangles by sides, making an equilateral with all three sides the same, isosceles with two sides the same, and scalene where none of the sides are the same length. But we also have the option of classifying them by angles, and we're going to focus on that today. If all of the angles are less than 90 degrees, we have acute. If one of them is 90 degrees, we have right. And if one of them is larger than 90 degrees, we have obtuse. So let's take a closer look at each of those three. The first one is acute. In an acute triangle, all three angles of the triangle have to be acute angles, meaning they all have to measure less than 90 degrees. Now, unlike classifying them by the sides, where you had to have either the actual length written in or the tick marks there showing that they were the same or not the same, that does not have to be the case for angle measures other than 90 degrees. You do have to have a 90-degree measure or a 90-degree angle measure marked, but the other ones don't. So if you can physically see that the angles all appear to be less than 90 degrees, you can say it's acute. Now, sometimes the measures will be given. So here in this green triangle, we could see we have 50, 56, and 74. So those are all less than 90 degrees, and that's pretty easy to see. In this pinkish color triangle down here, still triangle ABC, but there's no marks given, but we can see that all of those, if we were to use a corner of a piece of paper for 90 degrees, we can see that all of those are going to be less than that, even though they're not marked. We could still say, hey, this is an acute triangle. The second type is a right triangle. The right triangle, one angle in the triangle has to be a right triangle, meaning it has to measure exactly 90 degrees. Now, acute and obtuse don't need the markings, but a right angle has to be marked. You can never assume something to be a right angle. So it has to clearly say 90 degrees, or it has to have that little box. It does not have to have both. So even this one down here that doesn't have any names on the vertices, we know this is still a right triangle because it has that small square there in the corner indicating that that one is a right angle. And then our last one is obtuse. And in an obtuse triangle, one angle in the triangle has to be an obtuse angle. And remember, obtuse means measures more than 90 degrees. So if you were to take the corner of a piece of paper or something and place it right here along that bottom line, it would come up like this. That would be 90 degrees, and we know that this is larger than 90 degrees. Again, it does not have to be marked as such, but it can be. So this one shows us here, this angle is 120. That's the obtuse angle. Down here in triangle PQR, we can see that angle Q would be our obtuse angle. Again, it doesn't have to be marked. As long as we can see, it would be larger than a 90-degree corner. Now, when we are classifying triangles, we should be able to classify them both by sides and angles at the same time. So when you are looking at your triangle, you're going to look for the angles and the sides. So in this triangle right here, we can see that angle F is 130 degrees. So that's larger than 90. So it's obtuse. And then also because we have one tick mark here and one tick mark here on the sides, we know that two sides are the same length. So this is obtuse and isosceles. Our next one is a right triangle. We see that because it has this 90-degree angle mark here in the corner. But we also can see we have one tick mark on this leg, two tick marks on this leg, and three tick marks over here. And so those are all different lengths, meaning that that triangle is scalene. And then our last one is 67, 67, and 46. So we can see all of those are less than 90. So we're looking at an acute triangle. And the hint that 67 and 67, that occurred twice. So if I look up here, I have one tick mark and one tick mark, then this one's two. So they aren't all three the same, but two of them are. So we are looking at an isosceles triangle. Here's just a little chart in general to let you know kind of what can and can't happen. So you can have an acute scalene where all three sides are different, but all angles are less than 90. You can have a right scalene where we have a right angle, but all of the sides are different lengths. And you can have an obtuse scalene where you have a large angle and all three sides are different lengths. You can have an acute isosceles where you have two sides the same, but all of the angles are less than 90. You can have a right isosceles where you have a 90-degree angle and two sides are the same. And you can have an obtuse isosceles where you have a large angle and then two sides are the same. This one is the one that's different. We can have acute An equilateral. Remember, all three sides are the same and all three angles will be 60 degrees every time. So it's impossible to have a right equilateral or an obtuse equilateral because equilaterals have to have 60-degree angles. When you are classifying by angles, or when you're thinking about your triangles by angles, acute and obtuse don't really have any major properties that are associated specifically with their type of triangle, but the right triangle does. The right triangle actually has several properties that are true about it. Tomorrow in our next lesson, we're going to talk about the parts of the right triangle and then also a couple of properties that exist for it. See you tomorrow.